Objective 2. State properties of students' t-distribution. In example 1, a different random sample of 16 cars would likely result in a different point estimate of population mean mu. For this reason, we want to construct a confidence interval for the population mean, just as we did for the population proportion. A confidence interval for the population mean is of the form point estimate plus or minus the margin of error, just like the confidence interval for a population proportion. To determine the margin of error, we need to know the sampling distribution of the sample mean. Now recall that the distribution of x bar, the sample mean, is approximately normal if the population from which the sample is drawn is normal or the sample size is sufficiently large. In addition, the distribution of the sample mean has the same mean as the parent population. So the population mean of the sample means is equal to the population mean, and a standard deviation equal to the parent population standard deviation divided by the square root of the sample size. So the population standard deviation of the sample means is equal to the population standard deviation divided by the square root of n, which is the sample size. Now, following the same logic used in constructing a confidence interval about a population proportion, our confidence interval is going to be the following. The point estimate, which is x bar, plus or minus the margin of error. Well, the margin of error is the critical z-value times the population standard deviation divided by the square root of the sample size. Now, with the population standard deviation here that's given in this formula, this presents a problem because we need to know the population standard deviation to construct this interval. It does not seem likely that we would know the population standard deviation, but not know this population mean. So what can we do? So a logical option is to use the sample standard deviation, S, as an estimate of the population standard deviation. Then the standard deviation of the sampling distribution of x bar would be estimated by the following. So instead of using the population standard deviation symbol, now we're going to use the sample standard deviation of S. So therefore, our confidence interval is going to be the following. X bar plus or minus the critical z-value times S over the square root of n. Now, unfortunately, there is a problem with this approach. The sample standard deviation S is a statistic and therefore will vary from sample to sample. Using the normal model to determine the critical value Z in the margin of error does not take into account the additional variability introduced by using the standard deviation, the sample standard deviation, in place of the population standard deviation. This is not much of a problem for large samples because the variability in a sample standard deviation decreases as the sample size increases due to the law of large numbers. But for small samples, we have a real problem. So put another way, the z-score of x bar, which is x bar minus the population mean, divided by the population standard deviation over the square root of n, is normally distributed with a mean 0 and a standard deviation 1, provided that the sample mean is normally distributed. However, when we look at this formula, it is not normally distributed with a mean 0 and a standard deviation 1. So a new model must be used to determine the margin of error in a confidence interval that accounts for this additional variability. This leads to the story of William Gossett. In the early 1900s, William Gossett worked for the Guinness Brewery. Gossett was in charge of conducting experiments at the brewery to identify the best barley variety. When working with beer, Gossett was limited to small data sets. At the time, the model used for constructing confidence intervals about a mean was the normal model, regardless of whether the population standard deviation was known. Gossett did not know the population standard deviation, so he submitted the sample standard deviation for the population standard deviation and used the following formula. While doing this, he was finding that his confidence intervals did not include the population mean at the rate expected. So what this did is this led to Gossett to develop a model that accounts for the additional variability introduced by using S in place of the population standard deviation when determining the margin of error. Guinness would not allow Gossett to publish his results under his real name. Guinness was very secretive about his brewing practices, but did allow the results to be published under a pseudonym. Gossett chose student.